state transition matrix. Whatever the box I have put, that formula I already discussed in the previous thing. That formula is very important. We have to remember properties, state transition matrix formula we have to remember. Now the properties of phi of t. Phi of t is the state transition matrix. Phi of t is the state transition matrix. Okay, state transition matrix. Now phi of 0 equal to I. Why? Phi of t equal to e power at. Now you substitute wherever t is there with 0, e power 0 equal to 1. So 1 or I. I means unity matrix. I means unity matrix. 1 or absolute value 1. Okay, 1. This is 1, a value. And I is the matrix form 1. Matrix form 1. Now in the second formula, pi inverse of t. Okay, when we substitute, we will understand. So e power at whole inverse we are doing. Then that minus can be taken for t also. Okay, and this can be written as pi of minus t. Pi of minus t. This is what we are doing from LHS. From LHS, if I write like this, okay, this is nothing but RHS what I obtained. RHS what I obtained. And instead of the third one, I will just put one more formula. Pi of t1 plus t2, I can take it as pi of t1 into pi of t2. Pi of t1 into pi of t2. Okay, the third property I am slightly changing. Here the thing is pi of t equal to, the third one, pi of t equal to e power at. If you take pi of t1 plus t2, in the place of t, we have to put t1 plus t2. In the place of t, we have to put t1 plus t2. Base is same, so you can separate the powers. You can separate the powers. This you can write it as pi of t1 into this you can write it as pi of t2. Okay, that is how the proof for third point. Proof for third point. I have come with the proof for third point, and this is the this is the third property. This is the third property. I have striken off third property and I have written in the red color the third property. I have written in red color. I am not able to see the cursor. My face is visible, but my cursor eye is not working. Yes, this is the third property. Okay. Now coming to fourth one. Fourth property, pi of t2 minus t1, pi of t1 minus t2. So here e power a, in the place of t, I have to put t2 minus t1, because for everything the logic is pi of t equal to e power at. This is our standard formula. This is our standard formula. Okay. So this is one formula. This is one formula for pi of t. This is second formula for pi of t. We have to remember. Second formula for pi of t we have to remember. State transition matrix. Two formulas are there. Now in that case, I am putting here e power a, and in the place of t, t1 minus t0. When you combine them, base is same, powers you can just add them. at2 minus at1 plus at1, then minus at0. And here plus at1 minus at1 will get cancelled. E power a you can take common. Okay, a you can take common. T2 minus T0 is present. T2 minus T0 is present. So in the place of T, we have T2 minus T0, and that's why I'm getting the RHS finally. I'm taking LHS. Okay, I'm taking LHS, and for the LHS, I'm just substituting like this. LHS, I'm substituting like this, and I have finally got the RHS. This is the proof for fourth one. This is the proof for fourth one. So all the black color are the properties. Additional things I am writing the proof in green and red color. Okay. And the last property, pi of t whole power t k. Pi of t whole power k equal to pi of kt. So pi of t means e power at, and whole power k you can do. And then e power a into kt you can combine. Now in the place of t we have kt. So we can write kt. I reached RHS. I have started with LHS. I have started with LHS. Okay, for LHS, I am writing like this because on the top I have a formula. Wherever pi of t is there, I can write e power at. So I have started with LHS. I slowly modified and got the RHS. Slowly modified and got the RHS. Okay, so RHS means this one. RHS means this one. Okay, so like that, these are the five properties. These are the five properties. Now I will go with 1 minute. So I'm taking 1 or 2 blank. Just I will recall. With that we can stop this class. Next class we will go with the problems. Okay, just I will recall what all the things we have discussed today. State space analysis. State space analysis. What are the advantages for higher order system? Multiple input, multiple output. Okay, it is applied a random input, we can apply accurate output, and then initial conditions are considered. Okay, nonlinear systems also we can apply. All these are the advantages in state space analysis. Secondly, we had some variables. Okay, we had some terminologies we discussed. What is state, state vector, state variable, state space, state model. All these are the terminologies we discussed. What is state? Okay, state variables means what are the variables used, and then state vector means all the variables together, it is called vector. Then state space means how many dimensions we are using, and state model. State model means we had 2 equations. These are the things we discussed. Thirdly, what is the state model? State model, we will have 2 equations, x dot equal to ax plus bu, and then y equal to cx plus du. This is state model. First equation is state equation, second equation is output equation. First equation, state equation, and the second equation is output equation. This is the third thing we discussed. Then the ABCD are matrices. ABCD are matrices, comma, U is input, Y is output, X is state vector, X is state vector, X dot is derivative of state vector. Okay, derivative, first order, derivative of state vector X. Okay, these things we discussed. And ABCD dimensions, they are constant matrices, constant values matrices. Next, we had gone with the transfer function. Transfer function is nothing but C into Si minus A whole inverse B plus D. This is the formula for transfer function. Fifthly, we have gone with state transition matrix. Fifthly, we have discussed what is state transition matrix, and it is represented by pi of t. And 2 formulas are there. E power at can be one formula. Other formula, inverse Laplace of Si minus A inverse. Inverse Laplace of Si minus A inverse. These 2 are the formulas for state transition matrix. And lastly, the properties of state transition matrix. Properties of state transition matrix. Okay, so first property, pi of 0 equal to I. Second property, pi inverse of t is nothing but pi of minus t. And third property, pi of k t is nothing but pi of kt. Third property. Fourth property, it is pi of t1 plus t2. It is equal to pi of t1 into pi of t2. Pi of t2. And the last property, it is t2 minus t1. Then we have t1 minus t0. We can combine them together and write t2 minus t0. T2 minus t0. These are properties in state transition matrix. These are the things we discussed for today. Okay, these are the basics or the theory what we discussed for state space analysis. Okay, we have the last one here, controllability, observability, I will take up in the next session. This is the last one here. The first 2 equations are together called a state model. First 2 equations together called a state model. Non-homogeneous means input need not be 0. Okay, non-homogeneous. Earlier we have taken homogeneous condition and derived the equation you can see for state model. Okay, the state transition matrix. Homogeneous means we have to take input 0. Complementary function means we have to take input 0. And non-homogeneous means we will not take input 0. We will consider the input in the calculations. Then it is called non-homogeneous. Okay, this is equation 1 state equation. This is output equation. All the background derivation, finally we are getting this equation. Finally we are getting this equation. Here we have x of t, which is the initial condition of the system at a time t naught. Initial condition of the system at time t naught. Here we have two things, inputs are present. Inputs are present. Okay. Now, the first term, if the second term is 0, input is 0, then it is called zero input response. Only first term will remain. Equation 3 is the final equation after some background derivations here. If second term is input is 0, if second term 0, input is 0, only first term will remain. Okay, only first term will remain. Here you have integration, so you have a full thing where integration to be applied. And only first term remain means zero input response. First term is called zero input response. If initial conditions are 0, first term completely will be 0. In that case, only second term will remain. So it is called zero state response. This is called initial state or initial condition. Initial state or initial condition. If that x of t naught, the small x of t naught is 0 means that is called zero state. Zero state. In that case, first term completely becomes 0. Only second term will remain. And that second term alone is called zero state response. And if both are present, input is present, initial state also present, then both the terms will remain. Equation 3 is called total response. Equation 3 is called total response. Response means output. Response means output y of t. Response means output y of t. This is in the case of non-homogeneous. Non-homogeneous solution means we will consider both input as well as initial condition in the calculation. Randomly, whether input may be 0 or initial condition may be 0, we will get zero state response, zero input.